All right, this is section 3.2, angles of triangles, and we have some more vocabulary words to add to our chapter so far. So some two new vocab words are interior angles, which are exactly what they sound like, angles that are inside of a polygon. And then the big one here, which you probably already knew, you may not have known the name for it, but it's the TriangleSum Theorem. And the TriangleSum Theorem states that the sum of the angle measures of the interior angles, so the inside angles, of a triangle is 180 degrees. And so basically, if, algebraically speaking, if I add angle X with angle Y and angle Z, no matter what kind of triangle I have, I'm always going to get 180. Now, that again, I mentioned this last lesson, that does not mean that they're supplementary angles, because supplementary angles are only two angles that add to 180, but all triangles do add to 180 degrees. All three of them will add to 180. So if I want to find out what one of the missing angles are, basically what I'm going to do is I'm going to subtract the two angles I do have from 180. Now I'm going to write this out algebraically so you could actually see, because that might be important later on if I don't have one as easy as this problem. It's always nice to know algebraically what's going on here. So I'm adding the three angles together, and the TriangleSum Theorem says if I add them together, it'll always be 180. And so then I add the two, or combine my two like terms. 32 plus 48 is 80. I subtract 80 from 180, and we get 100 for X. And then angle B, exact same thing here. I can add angle X with the 81 degree angle, with the 25 degree angle, and I know that's 180 degrees. I combine my like terms. The two angles I already have sum to 106 degrees. And if I subtract from 180, 180 minus 100 is 80, and minus 6 more is going to be 74. So X equals 74. All right, here's an example of why I like to do these problems algebraically, is because sometimes they're not always as simple as solving for one angle. Sometimes I have to solve for X, and it's in multiple angles. So the TriangleSum Theorem again says if I add the X plus 28 degree angle with that 90 degree angle that I have right here, with another X angle, I'm going to get 180 degrees, just adding all three of them together. And so I solved this equation by combining my like terms, 2X, and then 28 and 90 is going to be 118. And I'm going to subtract 118 from 180. Okay, so 2X equals, that's going to be 62. And then I can divide by 2 to find out that X is 31. And then for angle D, example D, solving for angle X, X plus X minus 35 plus 43 equals 180. And I don't need to use parentheses here because I'm just adding them all together, so it doesn't really matter what order I do that in. I do have to be careful, though, when I combine my like terms. I have to make sure I remember that this is a negative 35, and this is a positive 43. So when I combine those, I'm going to do different signs, subtract. So I'm actually going to get a positive 8 equals 180. And then I'm going to subtract 8 from both sides, which is 172, and then divide by 2. And that's going to give us 86 for X, which makes sense. If I go back and look, this angle is X degrees, and that looks like it'd be 86 because it's pretty close to being a right angle. Whereas over here, this one's 31, and if I look at that one, that looks 31, obviously would be an acute angle, and so that makes sense. This theorem you might not be as familiar with. It's the exterior angle theorem of a triangle. So an exterior angles are the angles that are adjacent angles extended outside the polygon. Obviously outside because they're exterior. So if I have a triangle, my exterior angles here are the ones highlighted in blue. Angles that are extended outside the triangle. And so we have a theorem that says the triangle exterior angle theorem states that the measures of an interior angle of a triangle equals the sum of the measures of the two non-adjacent interior angles. And so that's a really lengthy definition for something that's not super complicated. So when it says that it's the sum of the two non-adjacent angles, that's kind of important that we discuss that. Non-adjacent would mean not next to. So if angle Z is my exterior angle, the adjacent angle next to it would be this one that I'm marking with an X. And so that's not what we're talking about. When we say non-adjacent, we're saying not next to. So basically the two other angles, angle X and angle Y, if you add them together, their sum will give you angle Z. And that's because together, X and Y, along with this angle that I've marked with an X here, have to add to 180. But angle X with the Z degree angle also has to add to 180 because it sits on a straight line if we extend that side. So if angle X and the Z degree angle have to add to 180, and angle X and these two angles have to add to 180, then what we're saying is that X and Y together has to be the same as Z, so that everything will add to 180. So let's find the measure of each exterior angle. Now, it's asking us for the actual measure of the exterior angle, so I'm not just going to find X or Y or Z. I'm actually going to find out what the measure are. So I guess in example A and B, I'm finding X and Y, but once we get down to example C and D, I'll want to know exactly what that exterior angle measures. So I'm going to be labeling in degrees, which is kind of important to note here. So for example A, I know that the exterior angle is equal to the sum of the two non-adjacent interior angles, which just means 36 plus 72, and 30 and 70 makes 100, and 6 and 2 makes 8, so x equals 108 degrees. That was super simple. Example B, same deal here. The exterior angle y is equal to the sum of the two non-adjacent interior angles. Non-adjacent, again, meaning not next to, so y equals 70 degrees. And then in example C and D, again, I'm going to do the exact same thing, but it's 2a, not just a. So 2a, the exterior angle, is equal to the sum of the two non-adjacent interior angles. So a minus 5 plus 80. And so when I combine my like terms, that's going to be 2a equals a, and negative 5 and 80 makes positive 75. And so now I'm practicing something I did earlier in the year, which is using or solving equations with variables on both sides. And to do that, we're going to move the variable terms to the same side. And that's going to give us 1a, or just a, equals 75. So if a is 75, and I need to know what the exterior angle measures, then 2a is going to equal 150 degrees. So my final answer is 150 degrees. And then for example D, I know the exterior angle 4n minus 20 has to equal the sum of the two non-adjacent interior angles. So 2n plus 20 plus n. And so a lot of like terms to combine here. 4n minus 20 equals 3n plus 20, and then we're going to move some stuff around. So we can start by picking a side for a variable to be on, and it makes sense to subtract 3n and move the variable to the left to keep it positive. And then also move the constant over to the other side so that it's separated from the variable term. And so ultimately, when we're done with that, we have n equal to 40. So if n equals 40, I still have to find the measure of this exterior angle. So 4 times 40, I'm going to plug 40 in for n there. 4 times 40 is 160, and 160 minus 40, or sorry, minus 20 is 140 degrees. So my final answer is 140 degrees. All right, so let's review these two theorems we've talked about. We did the TriangleSum Theorem and then the triangle exterior angle theorem. So in this example, it says an airplane leaves from Miami and travels around the Bermuda Triangle. Find x. And so for the longest time, the Bermuda Triangle was this mysterious place where ships that traveled back and forth were getting lost or they were being found sunk. And so no one ever actually knew why. It was just kind of a mysterious place. And so now we have GPS and we can kind of have a better grasp on how to navigate. But it wants us to find x ultimately in this problem, and so all of the angles are on the inside. There's no exterior angle. So this is the TriangleSum Theorem, and I know that when I add the interior angles of a triangle together, that it's going to equal 180 degrees. So x plus 62.8 plus 2x minus 44.8 has to add up to 180 degrees. So when I combine my like terms, we have 3x, and then 62.8 minus 44.8 is just 18, equals 180. So we combine our like terms, our decimals actually make a nice constant number for us here. We're going to subtract 18 to the other side. So 3x minus 118 is 162. Oh, sorry, 180 minus 18 is 162. Sorry to confuse you there. And then we're going to divide that by 3. And that's going to give us 54. And so we have just found x. X is 54. Okay, let's look at a few other questions where we can use some of the vocabulary words we've been discussing this chapter. It says the measures of two complementary angles have a ratio of 3 to 6. What are the measures of each angle? And so we did a problem like this in our Chapter 7 review. But two complementary angles means they're going to add to 90 degrees. So angle x and angle x are going to add to 90 degrees. However, they have a ratio of 3 to 6. So 3x plus 6x is going to add to 90 degrees. So if I solve this equation by combining my like terms first and then solving for x, I find out that x is 10. But I'm actually not interested in what x is. I'm interested in what the measure of each angle is. So the first angle is 3x, and if x is 10, that makes it 30 degrees. And the second angle is 6x, and if x is 10, that makes it 60 degrees. So my two angles are 30 degrees and 60 degrees, and you can check, and they for sure are complementary because they add to 90. All right, let's check this next problem out. It says the measure of the second angle in a triangle is 4 more than the measure of the first angle, and the measure of the third angle is 8 more than twice the measure of the first angle. Find the measure of each angle. Okay, that sounds very complicated at first glance, and it looks worse than what it actually is. And so what I need to add 3 angles together, and because they're forming a triangle, I do know that they will add to 180. So let's start by calling the first angle x. We don't know what the first angle is. Let's just call it x. It says the second angle is 4 more than the first angle. So the second angle then is x plus 4. It's the first angle, but 4 more than that. So don't just put plus 4, but x plus 4. And then the third angle, it says, is 8 more than twice the measurement of the first angle. So again, the first angle is x. So 8 more than twice that would be 2x. There's your twice plus 8. So let's read this again. The measure of the second angle in a triangle is 4 more than the measure of the first. So here's the first angle. There's 4 more than the first angle. And then it says the third angle is 8 more than twice the first angle. So again, the first angle is x. So twice x would be 2x. Plus 8. And because they all form a triangle, I know that together these 3 angles will add to 180 degrees. This seems like a complicated problem, but once you write those angles down and just add them together, it's just a multi-step equation that we can solve by combining our x's. 1, 2, and 2 more makes 4, so 4x. And then combining our constants. 4 and 8 makes 12. Equals 180. Subtract 12 from both sides. 180 minus 12 would be 168. And then divide by 4. 4 goes into 16 4 times with nothing left over. 4 will go into 8 twice. So x is 42. It says find the measure of each angle though. Each angle. So I know the first angle is 42 degrees. The second angle is 4 more than that. So x plus 4 would be 46 degrees. And then the third angle is twice 42, so 84, plus 8. And 84 plus 8 is going to be 92 degrees. And so double check your answer. Make sure that all three of these add to 180, but 2 plus 6 plus 2 is 10. 9 and 1 makes 10, plus 4 and 4 is 18. So we do get 180 degrees. So our answer for this problem is 42 degrees for the first angle, 46 degrees for the second angle, and 92 degrees for the third angle. So if this didn't make sense, rewind this and watch it. But I think once you get these three angles written down here and you just add them to 180, then it becomes a lot easier of a problem. Let's look at some homework questions, starting with number 15. It says, describe and correct the error. And so I want to talk about this so we understand why the mistake was made. They're adding this to 180 degrees, but I don't have three interior angles. I have an exterior angle right here. So I can't use the TriangleSum Theorem and add them to 180 if I have an exterior angle. So I do know that the exterior angle, the 2x minus 12 degree angle, is equal to the sum of the other two non-adjacent angles, which is 30 and x. And so if I want to solve for x, which again, you do need to show your work for this problem, I don't care if it's multiple choice. So I need to write that equation down, and then I would start by moving the x over to the left side by subtracting x from each side. And then moving your constant term over to the right side by adding 12 to both sides. And we get a nice equation of x equals 42. So that would have to be this last option down here where it says the measure of the exterior angle is equal to the sum of the measure of the two non-adjacent interior angles, which I mentioned. The sum would be, or is not 180, but x would have to be 42 for that reason. So the exterior angle would be 2 times 42, which is 84, minus 12, which is 72 degrees. All right, number 18 says a triangle has an exterior angle with a measure of 120 degrees. Can you determine the measure of the interior angles? Explain. So if I have a triangle that has an exterior angle of 120 degrees, I do know that, I'll call this x and I'll call this y. I do know that those two angles have to add to 120. I also know that this angle would have to be 60. Write that a little bit smaller. But x and y could be any two numbers that add to 120. So there's really not enough information here. So I guess that would be option 3, right? The two non-adjacent interior angles could be any two angles that add to 120. That's all I know. I do know that it has to be 120, but it doesn't give me more information, so I can't tell you what they both are. If I knew what one of those other ones were, I could be for sure what the third angle is, but I do not know. So this next series of questions, homework questions, are going to be questions that we're going to be looking more in depth at on Friday with our triangle worksheet. And it says, determine whether the statement is always, sometimes, or never true. Explain your reasoning. Given three angle measurements, you construct a triangle. And this is going to be sometimes true. And the reason that's sometimes true is because, well, sometimes those three angle measures will add to 180 degrees. And sometimes they won't. And so I can only have a triangle if they add to 180 degrees. I won't say never because three angles could very well add to 180, but I can't say always because the three angles could be whatever they want it to be. So this is definitely a sometimes answer. Number 20, the acute interior angles of a right triangle are complementary. So let me start by drawing a right triangle. It says the acute interior angles, which will be referring to these two angles here, are complementary. Well, think about this. There's 180 degrees in a triangle, every single triangle, and I already know because it's a right triangle that 90 degrees is already accounted for. And so there's 90 degrees left. And so these two angles have to add to 90 degrees so that combined with that 90 degrees, we get 180. So if I have two angles that have to add to 90, then they are always going to be complementary. And number 21 says that a triangle has more than one vertex with an acute exterior angle. So the only way that we're going to get an acute exterior angle is if our triangle is an obtuse triangle, like this. In that case, the exterior angle, which I'm marking here with an X, would be acute. But again, I can only get an acute exterior angle if it's next to an obtuse angle. And because triangles have to add to 180 degrees, there cannot be more than one obtuse angle. Otherwise, it'd have to add to way more than 180. So in a triangle, there can only be one obtuse angle, and that means there can only be one acute exterior angles. The other exterior angles, whoops, go the other way. The other exterior angles are going to be obtuse. As you can see here, I'm kind of highlighting them here. I'll even shade them so we can see them a little bit better. These are the other exterior angles here. So they'd have to be obtuse. And so there's no way that I can have more than one acute. And so this one's never going to be true.